Given line segment AD is congruent to line segment CD, which statement is sufficient to prove that triangle ABD is congruent to triangle CBD? Okay, so let's mark the triangles that we're describing first. Triangle ABD, and triangle CBD. Not my best work. And they also told us that we have a congruent side. AD is congruent to CD. Getting that from here in the problem. Also visually, when we look at these triangles, they're sharing side BD. So that's another congruent side. We need 3 criteria since we don't know if these are right triangles or not. They look like they are, but they didn't tell us they are. Side, side, side. Side, angle, side. These are the 2 we're really looking at. There's also angle, angle, side. And angle, side, angle. So all 4 of these prove congruence, but since we already have 2 sides, I'm looking at these ones mainly right now. Because it looks like we're going to add 1 piece of information. So it might either be a side or an angle, and that would be enough to prove congruence. First thing is angle ABD. Let's use a different color. Angle ABD is congruent to angle CBD. So these angles do, correspond to each other, but in order, this is an angle, a side, and a side, like sequentially. And that, if you just use the first letter of those words, that spells a bad word. So that is the combination that does not prove congruence. Angle, side, side does not prove congruence. The order of these things matters. Side, angle, side means the angle that's congruent has to be between the sides. It would have to be this angle if we're going to use that congruence postulate. So option A is off the table because it spells the bad word. Not allowed. Option B is that side AD is congruent to side BD, which is interesting. I guess maybe they're trying to trick you into thinking that this would be side, 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 but side, 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 that means every side of the triangle is congruent to the corresponding side in the other triangle. What this would mean is that I guess these 3 side lengths are the same, but that is not enough information. I guess it makes them isosceles, and maybe you could do something with that, but that doesn't work for now. If nothing else works, maybe go back to it. Option C, angle BAD is congruent to angle CDB. One of these is in the right place for side, angle, side, but this angle does not correspond to that angle. The way they named them, a triangle ABD and triangle CBD. If what we have right now is that BAD, so like the angle on A, is congruent to the angle on D, these letters aren't in the same place, in the order of the letters. This is the way the angles corresponds. Angle A corresponds to C. Angle B corresponds to angle B. And then angle D should correspond to angle D, right? So this and this correspond, but this isn't helpful. If anything, that might prove that the triangles aren't congruent. So it's not option C. The last one is that ADB. That's promising. Is congruent to CDB. That's it. We have a side, an angle, and a side sequentially. So that is enough to prove congruence between these 2 triangles. So the answer is option D.